Good afternoon, everyone. So, in the last class, we discussed about the Darcy-Weisbach equation and like the major losses and minor losses. So, the major loss in the pipe law can be found out by using Darcy-Weisbach equation. That is nothing but the equation of head loss due to friction. And then the minor losses. So, the minor losses are the loss due to sudden expansion, sudden contraction. The loss occurs at the entrance of the pipe, loss occurs at exit of the pipe due to bending in the pipe, due to pipe fittings, and due to an obstruction in the pipe. So these are the different types of losses. And of course, in the last class, we discussed about the derivation for Darcy-Weisbach formula, and we discussed the formulas related to the minor losses. So the Darcy-Weisbach formula is given as HF, the head loss due to friction HF is equals to 4FL V square by 2ZD. Here HF is head loss due to friction, F is the coefficient of friction, L is the length of the pipe, V is the velocity of flow, and D is the diameter of the pipe. And using all the values, we can calculate the head loss due to friction. And of course, the coefficient of friction value was mainly depends on the value of Reynolds number. Suppose if the Reynolds number value is less than 2000, then to calculate the coefficient of friction, we can use the formula 16 by RE, that is the Reynolds number. And so if the Reynolds number is more than 4000 or greater than 4000, then the coefficient of friction can be calculated by using the formula 0.079 by RE power 1 by 4. Right? So these two are the formulas to calculate the coefficient of friction. And to calculate the Reynolds number, we have the formula rho V D by mu, isn't it? So using that formula, we can calculate the coefficient of we can calculate the Reynolds number, and using the Reynolds number we can calculate coefficient of friction, and using coefficient of friction, diameter, length and velocity we can find out the head loss due to friction, right? So these are the formulas, and of course in the last class we discussed some of the problems related to this one also, isn't it? Right? So let's go to the problem related to the minor losses. So these are the minor losses. The loss may be occurred due to sudden enlargement, loss occurs due to sudden contraction, loss of head occurs at entrance of the pipe, loss of head occurs at exit of the pipe, loss of head due to an obstruction, loss of head due to bending, loss of head in the various pipe fittings. So these are the different losses. So let's come to the loss of head due to sudden enlargement. For this one, the equation is loss of head due to sudden enlargement is denoted with H suffix E, and the equation V1 minus V2 whole square by 2Z. Here V1 is velocity before enlargement and V2 is velocity after enlargement. Then next one, loss of head due to sudden contraction. So to calculate the loss of head due to sudden contraction, the formula is Hc is equals to 0.375 V2 square by 2Z, where V2 is nothing but velocity occurs after enlargement or after contraction. Velocity occurs at after contraction. Or also we can use another formula, that is head loss due to contraction Hc is equals to V2 square by 2Z into 1 by Cc minus 1 whole square. Hc is equals to V2 square by 2Z into 1 by Cc minus 1 whole square. And so this is the another formula to calculate the head loss due to contraction. So let's solve a problem on already we discussed about the head loss due to enlargement, right? So let's go to the contracted one. Okay, listen, I'm going to read the problem. A horizontal pipe of diameter 500 mm is suddenly contracted to a diameter of 250 mm. The pressure intensities in the large and smaller pipe is given as 13.734 Newton per centimeter square and 11.772 Newton per centimeter square respectively. Find the loss of head due to contraction if coefficient of contraction Cc is given as 0.62. Also determine the rate of flow of water. So problem name ichadante they have given the diameter before contraction and after contraction. So before contraction the diameter d1 is 500 mm, after contraction the diameter 250 mm, and they have given the pressure intensities at section 1 and 2. At section 1 P1 is given as 13.734 Newton per centimeter square, and at section 2 PT is given as 11.772 Newton per centimeter square, and also they are given coefficient of contraction, that is 0.62. So using these values we should calculate loss of head due to contraction HC, and we should also calculate the rate of flow, that is the discharge. సో ఇక్కడ ప్రాబ్లంలో ఏమి ఇచ్చాడంటే డయామీటర్స్ ఇచ్చాడు, ప్రెషర్ ఇచ్చాడు, హెచ్సి క్యాలిక్యులేట్ చేయమన్నాడు అండ్ డిశ్చార్జ్ క్యాలిక్యులేట్ చేయమన్నాడు. సో ఎప్పుడైనా కానీ ప్రాబ్లంలో మీకు ప్రెషర్ వాల్యూస్ ఇచ్చారు అంటే సో యూ హ్యావ్ టు ఆల్వేస్ యూజ్ ది బెర్నౌల్లిస్ ఈక్వేషన్. యూ షుడ్ రిమెంబర్ దట్. ప్రాబ్లంలో ప్రెషర్ బిఫోర్ ద సెక్షన్ అండ్ ఆఫ్టర్ ద సెక్షన్ అని ఇచ్చాడు అంటే డెఫినెట్లీ యూ హ్యావ్ టు యూజ్ ద బెర్నౌల్లిస్ ఈక్వేషన్, అండ్ యూజింగ్ దట్ బెర్నౌల్లిస్ ఈక్వేషన్ ఓన్లీ you can solve the remaining values, and those so if they have given the pressure values, then definitely you have to go for the Bernoulli's equation. So let's write the given data. The diameter before contraction, that is d1 is 500 mm, converting into meters 0.5. Then calculate the area. A1 is given as pi d1 square by 4, that is 0.1963 meter square. Then after contraction d2 250 mm, that is 0.25 meters, and the area will be pi d2 square by 4. Then we get 0.04908 meter square. Then pressure P1 is given as a Newton per centimeter square. To convert into meters, we should multiply with 10 power 4, and similarly P2 also. Then they have given Cc. So what we should calculate? We should calculate the head loss due to contraction Hc. What is the formula? So first write the formula. The formula to calculate the Hc value, the formula is V2 square by 2Z into 1 by Cc minus 1 whole square. So they have given the value for Cc. Substituting that we get 0.375 V2 square by 2Z. But here we don't know V2 value to calculate the head loss due to contraction. So to calculate V2, we can use one formula, that is continuity equation. From continuity equation we can get A1 V1 is equals to A2 V2, and from there V1 is equals to A2 V2 by A1. So here we know the values for areas. So using the areas, by substituting the areas we can get V1 as V2 by 4. Substituting the area values we can get V2 by 4. Simplifying that we can get the value as V2 by 4. Now let's take the Bernoulli's equation to find out the velocity at another section. Then by taking the Bernoulli's equation, the equation P1 by rho z plus V1 square by 2z plus Z1 is equals to P2 by rho z plus V2 square by 2z plus Z2, including the head loss due to contraction, that is Hc. And we know that for horizontal pipe Z1 is equals to Z2, and the remaining will be P1 by rho z plus V1 square by 2z is equals to P2 by rho z plus V2 square by 2z plus Hc. And we know the value of V1, that is V2 by 4. So substituting the value and substituting Hc value. What is Hc? 0.375 V2 square by 2z. Right? So substituting all the values in this equation, the value of Hc and value of V1 in this equation, and simplifying this, we can get the value of V2 as V2 is equals to 5.467 meters per second. So ఇక్కడ ఏం చేసామంటే Bernoulli's equation, this is our Bernoulli's equation, and in this Bernoulli's equation we have substituted the value for V1. V1 is equals to V2 by 4, and also we have substituted Hc is equals to 0.375 V2 square by 2z. So we have brought all the values in terms of velocity at section 2. So now substituting the values in terms of velocity at section 2 and simplifying these values, we can get V2 as 5.467 meters per second. And now we can calculate the head loss due to contraction as the formula 0.375 V2 square by 2Z. Then substituting V2 value as 5.467, we can get the head loss due to contraction as 0.571 meters, and also we should calculate the discharge. So to calculate the discharge, the formula will be Q equals to A to V2. We know the area and we know the velocity. Substituting that, we can get the discharge as 0.2683 meter cube per second. So the problem may be small, but the solution may be the biggest one. So problem lo em ichado clear ga chudandi. Problem lo diameters, pressures and contraction ichesadu. But manaku kavalsindi head loss to contraction or any head loss, that may be minor loss or major loss, whatever. To calculate any head loss, the most important parameter is the velocity. Right? What we should calculate is the velocity. So to calculate the velocity, we can use the continuity equation as well as the Bernoulli's equation also. Right? So problem lo pressures ichadu kabatti manam em chestunamante Bernoulli's equation తీసుకున్నాం. సో Bernoulli's equation నుంచి మనం సింప్లిఫై చేసుకుంటూ రావాలి కాబట్టి కంటిన్యూటీ ఈక్వేషన్ తీసుకొని కంటిన్యూటీ ఈక్వేషన్ ని in terms of V1 ni in terms of V2 గా తీసుకున్నాం. From the continuity equation we have taken V1 in terms of V2, and also we have the formula to calculate head loss due to contraction, that is Hc equals to V2 square by 2Z into 1 by Cc minus 1 whole square. We have Cc value and we can write the head loss due to contraction as in terms of V2 only. So now we have substituted the value for V1 and the Hc value in the Bernoulli's equation, and substituting the values of pressure and the rho Z values, V1 value and Hc value in this formula, and simplifying this one, we can get the value for velocity, right? And finally getting the velocity, now we can calculate the head loss due to contraction using the formula 0.375 V2 square by 2Z, and the discharge Q equals to A2 into V2. That's it. Right guys? So that is the formula to calculate the velocities and head loss due to contraction. So మనకి ఎప్పుడు కూడా ఎనర్జీ లాసెస్ మీద ప్రాబ్లం ఇస్తే డైరెక్ట్ గా వెలాసిటీస్ ఇవ్వడు. We should calculate the velocity using the given value. So by using the given value, definitely we should go for only two formulas. The first formula is the continuity equation and the second formula is Bernoulli's equation. Using continuity equation and using the Bernoulli's equation only, we can calculate these. We can calculate the velocity, and by knowing the velocity, we can calculate the losses. Right? So that is the procedure always. So let's discuss another problem. Okay. So problem is a 150 mm diameter pipe reduces in diameter abruptly to 100 mm diameter. If the pipe carries water at 30 liters per second, calculate the pressure loss across the contraction. Take the coefficient of contraction as 0.6. So pressure loss calculate cheyamanaru. The given data is D1 150 mm and converting to meters value 0.15. Area pi D1 square by 4 and D2 is given as 100 mm. That is 0.1 meters. Then the area will be, this is not 1.1, this is 0.1. 100 divided by 1000, then it will be 0.1. And A2 will be pi D2 square by 4. We can get the value 0.007854 meters square. Then they have given the discharge and also they have given coefficient of contraction. So now we have the value for discharge already. So discharge undi kabatti directly we can calculate the velocities by using continuity equation, isn't it? So velocities continuity equation nunchi easily calculate cheyochu. Discharge iవ్వకపోతే మాత్రం definitely we should go for the Bernoulli's equation to calculate the velocities. Pressure is K. So use the continuity equation. From continuity equation, A1 V1 is equals to A2 V2 and which is equals to Q. And from there, V1 will be Q by A1 and V2 will be Q by A2. We know all the values, and substituting the value, we can get the V1 velocity at section 1 1.697 meters per second, V2 Q by A2 which is equals to 3.82 meters per second. So what did they ask? They asked to find out the pressure loss. So to calculate the pressure loss, definitely we should go for the Bernoulli's equation. So applying the Bernoulli's equation, we get P1 by rho z plus V1 square by 2z plus Z1 is equals to P2 by rho z plus V2 square by 2z plus Z2 plus Hc. For horizontal pipe, Z1 will be equals to Z2, so we can cancel this one. And we know that Hc will be V2 square by 2z into 1 by Cc minus 1 whole square. We know the velocity at section 2 and we know the value for Cc also, they have given in the problem. So simply we can substitute all and we can calculate the head loss due to contraction, that is the value as 0.33. So now substitute the values P1 by rho z plus V1 square by 2z. We know V1 and we know G. Substituted the value, then equals to P2 by rho z plus V2 square by 2z plus Hc. So we have all the values except pressures. So substituted all the values and from there the pressure loss. The pressure head loss will be P1 by rho z minus P2 by rho z and the value 0.9271 meters. By simplifying this, we can get the difference of pressure head. From there, the pressure loss. The P1 by rho z minus P2 by rho z is pressure head loss. P1 by rho z is pressure head at section 1, but not pressure. Right? So P1 is the pressure and P1 by rho z is the pressure head. So there might be some difference between these two. Isn't it? So P1 by rho z and pressure head. P1 is the pressure. And in the problem they asked to calculate the pressure loss but not the pressure head loss. Pressure head loss and we should calculate P1 by rho z minus P2 by rho z. But problem lo pressure loss maatrame calculate cheyamanar. The pressure loss will be P1 minus P2 only. Isn't it? The pressure loss will be P1 minus P2. So that divided by rho z will send to the right side, then it will be rho z into 0.9271. We know rho is the mass density of water and the value 1000 kg per meter cube and G 9.81 into 0.9271 Newton per meter square. The pressure will be in Newton per meter square. The pressure head will be in meters of water. You should remember that. Pressure head ఎప్పుడు మీటర్స్ లోనే ఉంటుంది. Pressures will be in Newton per meter square. So now we get the pressure difference or the pressure loss P1 minus P2 will be 0.909 Newton per centimeter square. So that's what they asked to calculate. So do you understand? Problem lo pressure loss calculate cheyamannadu. So pressure loss calculate cheyadaniki area diameters, discharge and contraction ichesadu. So to calculate the pressure loss, that is P1 minus P2, we have taken the continuity equation as well as the Bernoulli's equation. So in the Bernoulli's equation, we have all the values and we have substituted that. So substituting that value and simplifying this, we can get the pressure loss P1 minus P2 is equals to rho z into the value of what we get in terms of meters of water. Okay, finally, we can obtain the value as P1 minus P2 0.909 Newton per meter square. Okay guys, so that is the value we can obtain from the pressure loss. So do you understand the problem? Guys, meeku problem ela solve cheyalo arthamainda? Do you have any doubts? Whatever the given problem, while calculating the losses, maybe major loss or minor loss. So in the major loss, we can include one more formula, that is the Reynolds number. But during the minor losses, we can use only two formulas. One is the continuity equation and another one is the Bernoulli's equation. So do you understand guys about this? Send a text message. Anyone?
Yes, ma'am.
Arthamainda? Any doubts? రిప్లై అండి, మీరు రిప్లై ఇస్తే కదా నేను నెక్స్ట్ స్టెప్కి వెళ్ళగలుగుతాను. ఎక్కడైనా డౌట్ ఉందా, లేదా ప్రాబ్లం ఎలా సాల్వ్ చేయాలో అర్థమైందా?
అర్థమైంది మ్యామ్.
Okay, so I will go for the another topic. So another topic is pipes in parallel and series. The next topic is flow through pipes in series or flow through compound pipes. Suppose if one pipe and another pipe is connected in series, then what would be the head of water which was flowing through the pipe? So to find out that, we are going to arrange the different pipes in series like this. So one pipe is fixed to the another pipe and another pipe is fixed to the one more pipe like this. So here we are sending the water from one level to another level. So during this flow, we are going to arrange different types of pipes, and those pipes are having different diameters. So the diameter may be suddenly contracted or suddenly enlarged like this. So during this case, the total head of water which was flowing through the pipes, the total head which was flowing through the pipe while connecting into series. So to calculate this one, let's take the different lengths of the pipe, where L1, L2, L3, or the length of the pipe at first pipe, second pipe and third pipes. D1, D2, D3 are the diameters of the pipe. V1, V2, V3 are the velocities in the pipes, and F1, F2, F3 are the coefficient of friction for the pipes. And consider H as the difference of water level in the two tanks, from the tank A to tank B. This is the difference of water level which was flowing through the pipe. The H is considered as the difference of water level in the two tanks. So now let's take, we have three pipes. So for these three pipes, by taking the continuity equation, the discharge which was flowing through the pipe will be same. Why? Because here the pipes are connected in series. So the discharge will be same, and the formula will be Q equals to A1 V1 equals to A2 V2 equals to A3 V3. And let's write the difference in the liquid surface. And that value is that the H value is equal to sum of the total head loss in the pipes. So the total head loss will be equals to the different losses which were occur on the pipe. So coming to the first one, here the pipe is suddenly contracted here, isn't it? Here the pipe is suddenly contracted. So that in the first pipe we can get the head loss due to contraction, and the equation will be 0.5 into V1 square by 2Z. Here the velocity in this pipe will be V1, so the velocity will be V1 square by 2Z. Plus there might be some friction was occurred, so let's take including that friction, then the head loss will be 4 F1 L1 V1 square by 2Z D1. Then coming to the second pipe, in the second pipe the water is again contracted. So ఈ diameter కి difference చూస్తే ఈ diameter నుంచి ఇక్కడికి ఇది contract అయింది. So here we have taken the contracted one, and ఈ diameter కి again contracted. So here also we can face the head loss due to contraction only. So that the formula, the head loss occurs in the pipe will be 0.5 V2 square by 2Z. Why? Because the velocity flowing in this pipe will be V2. And including the friction, there might be some friction is also acting, then that will be 4 F2 L2 V2 square by 2Z into D2 place. And here the pipe was suddenly enlarged. So here the pipe is enlarged from V2 to V3 with the velocity V2 to V3. so that the head loss due to enlargement will be V2 minus V3 whole square by 2Z. So due to enlargement from V2 to V3, the diameters will be V2, the velocities will be V2 minus V3 whole square by 2Z, plus the friction for the friction acting in the third pipe for F3 L3 V3 square by 2Z D3, plus again the pipe was suddenly enlarged, isn't it? Or the pipe is suddenly occurs at the exit. So at the exit, the head loss will be V3 square by 2Z. At the exit, the head loss will be V3 square by 2Z. So these are the different losses we can face during the flow of pipe. So these are the different losses we can face during the flow of the pipe, isn't it? So first ఏంటంటే at the entrance or due to sudden contraction of the pipe, the loss may be due to sudden contraction as well as the friction. And coming to the second pipe, the pipe was again contracted. So here also we can face the head loss due to contraction and as well as head loss due to friction. Then coming to the third pipe, here the pipe was enlarged. So here the head losses are head loss due to enlargement plus head loss due to friction. And finally, the loss occurs at the exit of the pipe. So at the exit, the loss will be V3 square by 2Z. So these are the different losses we can face along the pipe. And if we neglect the minor losses, so here the minor losses are very, very small. So we can neglect these losses, then this above equation will become as H equals to 4F1 L1 V1 square by head loss due to friction at first pipe plus head loss due to friction at second pipe plus head loss due to friction at third pipe only. And usually the coefficient of friction will be very, very small for all pipes, so that we can take F1 is equals to F2 is equals to F3 as F. So we can take the friction as very small and hence we can consider it as F only. And substituting that, the head loss equation, the total head loss occurs from first pipe to second pipe will be H equals to 4F by 2Z into L1 V1 square by D1 plus L2 V2 square by D2 plus L3 V3 square by D3. Right? So this is the equation while connecting all the pipes. This is the equation of head loss while connecting all pipes in series. If the pipes are connected in series, then the equation will be the total head loss H equals to 4F by 2Z into L1 V1 square by D1 plus L2 V2 square by D2 plus L3 V3 square by D3. Right? So this is the equation. So do you understand, guys? Here the water is flowing from tank A to tank B. So while flowing the water from tank A to tank B, there are different pipes are connected in series. One pipe is connected with another pipe. And individual pipes are having individual lengths, diameters, velocities and frictions. So by considering these pipes and by taking the arrangement of these pipes, we can calculate the total head loss which was occurred from first tank to second tank, from tank A to tank B. So to calculate that, we have taken the head loss formula. So to calculate the total head loss, we have considered the different pipe sections, and in the different pipe sections, the different minor losses and major losses. So by considering those losses, we can write the different losses occurred on the pipe. So let's come to the first pipe. Here the pipe is suddenly contracted or at the entrance. We can take any one at the entrance of the pipe or contracted one. So contraction of the pipe. Then by taking the loss of head at the entrance or loss of head due to sudden contraction, the equation will be Hc, that is 0.5 V1 square by 2Z, plus the friction is also acting here, so that the friction 4F1 L1 V1 square by 2Z D1. Plus in the second pipe, the pipe is suddenly contracted. So due to its contraction, the minor loss will be 0.5 V2 square by 2Z. Here the pipe velocity is 0.5 V2 square by 2Z, plus the friction is also acting here, so the head loss due to friction at second pipe 4F2 L2 V2 square by 2Z D2. Plus coming to the third pipe, here the third pipe was suddenly enlarged from D2 to D3. So the velocities are V2 and V3. So that the head loss due to sudden enlargement will be V2 minus V3 whole square by 2Z. Plus here also the friction is already acting, that is F3. So due to that friction we can calculate head loss due to friction also. That is 4 F3 L3 V3 square by 2Z. And finally the water will enters into a tank, will exit the pipe and enters into the tank, and here we can face some loss due to the exit. So at the exit the loss is V3 square by 2Z. Here the velocity is V3. So at the exit the loss can be calculated by using V3 square by 2Z. And if we neglect all minor losses, why? Because the minor losses are very, very small losses. So that we can neglect these losses, and by considering the friction in all pipes are same, we can get the final equation for head loss from tank A to tank B, that is H equals to 4F by 2Z into L1 V1 square by D1 plus L2 V2 square by D2 plus L3 V3 square by D3. Right? So single pipe anukondi, single pipe aithe simple ga head loss, entrance, exit pipe lo ఏ friction act అవుతుందో ఆ friction బేస్ చేసుకొని క్యాలిక్యులేట్ చేసేయచ్చు. బట్ ఇక్కడ డిఫరెంట్ టైప్స్ ఆఫ్ పైప్స్ ఒక సిరీస్ లో కనెక్ట్ అయింది, ఒకదానికొకటి సిరీస్ గా కనెక్ట్ అయింది, ఇజంట్ ఇట్? సో సిరీస్ గా కనెక్ట్ అయినప్పుడు then to calculate the total head loss from first tank to second tank during the flow, definitely we should go this formula, that is 4F by 2Z into L1 V1 square by D1 plus L2 V2 square by D2 plus L3 V3 square by D3. So usually మనకి ఓవర్ హెడ్ ట్యాంక్ నుంచి మన హౌసెస్ కి వాటర్ వస్తుంది, ఇజంట్ ఇట్? సో ఓవర్ హెడ్ ట్యాంక్ నుంచి హౌసెస్ కి వాటర్ వస్తున్నప్పుడు బ్రాంచ్ కెనాల్స్ పైప్స్ ద్వారానే వాటర్ ఫ్లో అవుతుంది. సో ఈ పైప్స్ ఒక ఏరియాలో ఒక డయామీటర్, ఇంకొక ఏరియాలో ఇంకొక డయామీటర్ తో ఉండొచ్చు, అండ్ నెక్స్ట్ మన ఇంటికి రీచ్ అయ్యేసరికి డయామీటర్స్ చేంజ్ అవుతూ ఉండొచ్చు. ఇలాంటి కేసెస్ లో టోటల్ లాస్ ఒక పైప్ లో ఓవర్ హెడ్ ట్యాంక్ నుంచి మన ఇంటి వరకు వాటర్ రీచ్ అయ్యే పీరియడ్ లో ఎంత లాస్ జరిగింది. సో ఎందుకంటే ఇక్కడ పైప్స్ అన్ని ఒకదానితో ఒకటి సిరీస్ గా కనెక్ట్ అయి ఉన్నాయి, ఇజంట్ ఇట్? సో ఇలా ఒకదానితో ఒకటి సిరీస్ గా కనెక్ట్ అయినప్పుడు ఓవర్ హెడ్ ట్యాంక్ నుంచి మన ఇంటికి వస్తున్నప్పుడు టోటల్ లాస్ ఎంత జరిగిందో క్యాలిక్యులేట్ చేయడానికి we can use these formulas. Okay, so in those cases these the total head loss from overhead tank to house can be calculated by using these formulas. Okay guys, so let's solve a problem on this. The difference in water surface level in two tanks which are connected by three pipes in series of length 300 meter, 170 meter and 210 meter, and of diameters 300 mm, 200 mm and 400 mm respectively, is 12 meters. The difference of water surface level is 12 meters. Determine the rate of flow of water if coefficient of friction are 0.005, 0.0052 and 0.0048 respectively. Consider minor losses also. So minor losses ni consider cheyamannadu, neglect cheyaddu annadu. And considering minor losses, and the second case neglecting the minor losses, right? So by considering the minor losses and by neglecting the minor losses also, we should calculate the rate of flow of water, right? So we should calculate the rate of flow of water. Problem lo em ichadu, the difference in water surface level in two tanks, tank A nunchi tank B ki difference in water surface level is 12 meters. Total head loss, total head of flow enta ante h value ichesadu, that is 12 meters. Then length of the pipes L1 300, L2 170, L3 210 meters ichesadu, and also diameters D1 300, D2 200, D3 400, and also frictions ichadu 0.005, 0.0052, F3 0.0048. Right, so these are the diameters and lengths and the frictions they have given in the problem. So the first one, considering the minor losses, we should calculate the discharge. We should calculate this discharge, right? So for that one, let's take the velocities. Consider the velocities V1, V2 and V3 which were flowing in the pipe, and by taking the continuity equation, so if the pipes are connected in series, then the discharge which was flowing in the pipe is also same, so that all the areas and velocity, the multiplication of area and velocity are equal. That is A1 V1 equals to A2 V2 equals to A3 V2. Now let's calculate the velocities. So to calculate the velocities, one second guys. Okay, sorry for inconvenience. So using this continuity equation, we can calculate the velocities. So let's take A1 V1 equals to A2 V2 from this relation. A1 V1 equals to A2 V2. From this relation, we can calculate the value of V2 in terms of V1. We can calculate the value of V2 in terms of V1. So from this A1 V1 equals to A2 V2, V2 equals to A1 V1 by A2. We know the value for A1 and A2 because we know the diameters D1 and D2. So pi D1 square by 4 and pi D2 square by 4. Then substituting the value, we can get the V2 in terms of V1 as 2.25 V1. And similarly, let's take the another one. A1 V1 is equals to A3 V3. And from there, V3 is equals to A1 V1 by A3. So we know the diameter, so we can calculate the value of velocity at third pipe in terms of V1. Then it will be 0.5625 V1. Now, by considering the losses, considering the minor losses, the equation will be H equals to, so first of all, you can draw the figure. మీరు ఇచ్చిన ప్రాబ్లమ్ని బేస్ చేసుకుని ఫిగర్ డ్రా చేశారంటే ద డయామీటర్స్ బేస్డ్ ఆన్ ద డయామీటర్స్ అండ్ బేస్డ్ ఆన్ ద లెంత్ ఫిగర్ డ్రా చేసుకున్నారంటే రైటింగ్ ద హెడ్ లాసెస్ విల్ బి వెరీ వెరీ ఈజీ టు యూ. సో ఫస్ట్ వాడు ఇచ్చిన డయామీటర్స్ బేస్ చేసుకొని డ్రా ద ఫిగర్. So if you draw the figure, then writing the equation will be very very easy to you, isn't it? So this is the equation, as you know. Loss occurs at the entrance, then friction in the first pipe, then loss due to contraction, friction in the second pipe, loss due to enlargement, friction in the third pipe, and loss occurs at the exit. So let's write all the values. We have the friction value, we have the length, and also we have V2 in terms of V1 and V3 in terms of V1. So substitute all the values and get the total equation in terms of V1 like this. We know H value also. So H equals to 12, and substituting all the value and getting all the value in terms of V1, we can get the equation will be so on, so like this. And finally, we can get the V1 value. Simplifying that, we can get V1 value as V1 equals to 1.407 meters per second. Now, we can calculate the rate of flow. Problem adin ade kada, rate of flow ne kada calculate cheyamannadu. So the rate of flow can be calculated by using the formula Q equals to area into velocity, that is A1 into V1. So the formula will be pi D1 square by 4 into V1. We know the diameter and we know the velocity, and we can get the discharge as 0.09945 meter cube per second. So ఇక్కడ మనకి డిశ్చార్జ్ క్యాలిక్యులేట్ చేయాలి. డిశ్చార్జ్ క్యాలిక్యులేట్ చేయాలి అంటే కంపల్సరీ ఏరియా అండ్ వెలాసిటీ తెలియాలి. ఏరియా అండ్ వెలాసిటీ తెలియాలి కాబట్టి వెలాసిటీస్ ప్రాబ్లంలో ఇవ్వలేదు. సో ఏం చేసామంటే కంటిన్యూటీ ఈక్వేషన్ తీసుకొని రిమైనింగ్ టూ వెలాసిటీస్ని ఇన్ టర్మ్స్ ఆఫ్ వన్ వెలాసిటీగా తీసుకున్నాం, రైట్? సో V2ని ఇన్ టర్మ్స్ ఆఫ్ V1 అండ్ V3ని ఇన్ టర్మ్స్ ఆఫ్ V1 గా తీసుకొని టోటల్ హెడ్ లాస్ ఫార్ములాలో ఆల్ వాల్యూస్ ఇన్ టర్మ్స్ ఆఫ్ V1 గా సబ్స్టిట్యూట్ చేసి సింప్లిఫై చేసి V1ని క్యాలిక్యులేట్ చేసాం. సో V1 వచ్చిన తర్వాత నౌ వీ కెన్ గెట్ ద డిశ్చార్జ్ యాజ్ ఏరియా ఇంటూ వెలాసిటీ, దట్ ఈక్వల్స్ టు A1 into V1. Okay guys, now neglecting the minor losses. So by neglecting the minor losses, we can get only in terms of friction, head loss due to friction at the first pipe, head loss due to friction at second pipe, and head loss due to friction at the third pipe. So here also we can take V2 in terms of V1 and V3 in terms of V1. Why? Because we don't know the value for V2 and V1. So let's take the value for V2 in terms of V1 and V3 in terms of V1 and substitute those values, and simplifying this again we can get the V1 value as 1.445 meters per second, and by neglecting the minor losses the discharge will be Q equals to area into velocity and the value 0.1021 meter cube per second. So by considering the minor losses the discharge 0.099, and by neglecting the minor losses the discharge 0.1021, right? So there is some difference between both. సో ప్రాబ్లంలో ఏం చేసామంటే మనం చేసింది సింపుల్గా V2 అండ్ V3 వాల్యూస్ని ఇన్ టర్మ్స్ ఆఫ్ V1గా తీసుకుని టోటల్ హెడ్ లాస్ ఫార్ములా రాసి వాల్యూస్ అన్నిటిని సబ్స్టిట్యూట్ చేసి ఇన్ టర్మ్స్ ఆఫ్ V1గా సబ్స్టిట్యూట్ చేసి సింప్లిఫై చేసి V1 వాల్యూని క్యాలిక్యులేట్ చేసాం, రైట్? సో V1 వచ్చిన తర్వాత డిశ్చార్జ్ క్యాలిక్యులేట్ చేసాం. అండ్ హియర్ ఆల్సో మైనర్ లాసెస్ నెగ్లెక్ట్ చేసిన తర్వాత కూడా బై కన్సిడరింగ్ ఓన్లీ ద మేజర్ లాస్ ఆర్ ఫ్రిక్షన్ లాస్ H values will be like this, and then substituting the H value, we can get H value and remaining values we can get V1 now, and again we can calculate the discharge as Q equals to A1 into V1. Okay guys, so like that we can solve any problem if we know the continuity equation. So మనం ఏం చేయాలంటే మెయిన్ గా ఇక్కడ తీసుకోవాల్సింది కంటిన్యూటీ ఈక్వేషన్. కంటిన్యూటీ ఈక్వేషన్ నుంచి వెలాసిటీస్ క్యాలిక్యులేట్ చేసి వెలాసిటీ నుంచి డిశ్చార్జ్ క్యాలిక్యులేట్ చేస్తున్నాం. Okay. So this is the another problem. This problem is also same like the before one, the previous one. Head discharge L1, L2, L3, D1, D2, D3, F1, F2, F3, and here F1, F2, F3 is equal అన్నాడు. నెక్స్ట్ డిశ్చార్జ్ క్యాలిక్యులేట్ చేయమన్నాడు. సో డిశ్చార్జ్ క్యాలిక్యులేట్ చేయడానికి మనకి ఏరియా అండ్ వెలాసిటీ కావాలి కాబట్టి వెలాసిటీ తెలియదు, ప్రాబ్లంలో ఇవ్వలేదు. కంటిన్యూటీ ఈక్వేషన్ తీసుకొని V2 అండ్ V3 వాల్యూస్ని ఇన్ టర్మ్స్ ఆఫ్ V1గా తీసుకున్నాం. నౌ వీ హ్యావ్ గోన్ త్రూ ద హెడ్ లాస్, టోటల్ హెడ్ లాస్ వాల్యూ ఇచ్చేసాడు, అండ్ బై నెగ్లెక్టింగ్ ద మైనర్ లాసెస్ the formula will be HF1 plus HF2 plus HF3. So substituting the value we can get V1. Now we can calculate the discharge A1 V1, and then by considering the minor losses it will be at the entrance 0.5 V1 square by 2Z, contraction 0.5 V2 square by 2Z, and enlargement V2 minus V3 whole square by 2Z, and at the exit or outlet of the pipe V3 square by 2Z. So substituting all the value in terms of V1 and substituting the values, we can get the value of V1 here. V1 as 0.864 meters per second, and finally the discharge can be calculated as Q equals to A1 into V1. Same formula. So just మనం ఏం చేస్తున్నాము అంటే V2 and V3ని in terms of V1గా రాసుకొని ఫార్ములాలో ఆల్ ద వాల్యూస్ని V1లో సబ్స్టిట్యూట్ చేసి దాని నుంచి V1 తీసుకొస్తున్నాం. టోటల్ ఈక్వేషన్ని సింప్లిఫై చేసి V1ని తీసుకొచ్చాం. V1 తీసుకొచ్చి డిశ్చార్జ్ క్యాలిక్యులేట్ చేసాం. సో మైనర్ లాసెస్ కన్సిడర్ చేసినా చేయకపోయినా వీ హ్యావ్ ఓన్లీ ద వాల్యూ ఆఫ్ V1, and V2 is in terms of V1, and E3 is also in terms of V1. వాల్యూస్ అన్నిటిని V1లో సబ్స్టిట్యూట్ చేసి V1ని క్యాలిక్యులేట్ చేసి డిశ్చార్జ్ క్యాలిక్యులేట్ చేస్తున్నాం, రైట్? సో దట్ ఈస్ ద సింపుల్ ప్రాబ్లమ్. So next topic is equivalent pipe. Equivalent pipe is nothing but if all the pipes are having same diameters. Suppose if the all pipes are having same diameters, in that case the total head loss can be calculated by using the formula H equals to HF1 plus HF2 plus HF3 only. But here all the pipes are having same diameter, so that the total length which was flowing in the pipe, the equivalent pipe, can be L equals to L1 plus L2 plus L3. So from there, the equation, the total head loss in the compound pipe can be calculated by using the formula L by D power 5 is equals to L1 by D1 power 5 plus L2 by D2 power 5 plus L3 by D3 power 5. So very important formula in the competitive exams, right? Equivalent pipe ante length and diameter same ga undi. Ikkada contraction, expansion, enlargement, inlet, exit ilanti emi ledu. Length and diameter equal ga undi. Ilanti cases lo the total head loss can be calculated by using the formula as L by D power 5 is equals to L1 by D1 power 5 plus L2 by D2 power 5 plus L3 by D3 power 5. So using this formula, we can calculate the lengths and diameters, and finally we can find out the discharges. Right. The next topic, flow through parallel pipes. So in previous case, we have calculated the total loss by connecting the pipes in series, and now we are going to study the flow through parallel pipes. Suppose if the pipes are arranged parallel to each other. So this is the first pipe, you can see this is the first pipe and this is the second pipe. If this pipe and this pipe are connected parallel to one and another, in that case the total head loss can be calculated by using another formulas. So in this case what is happening is the total discharge will be divided for two pipes, that is into Q1 and Q2. The total discharge will be divides for two pipes, that is Q1 and Q2. So in this case, in case of series, the discharge is same for all the pipes, that is Q equals to Q1 equals to Q2 equals to Q3. But whereas if the pipes are connected in parallel, then the total discharge will be Q equals to Q1 plus Q2. Right? That is the main difference. Series ga connect cheste discharge in individual pipe will be same. That is Q equals to Q1 equals to Q2 equals to Q3. Whereas while connecting pipes in the parallel, the discharge will be Q equals to Q1 plus Q2. Okay, and also in this case, the head loss occurs in the first pipe will be equals to head loss occurs in the second pipe. ఇక్కడ ఎంతైతే లాస్ జరుగుతుందో ఇక్కడ కూడా అంతే లాస్ జరుగుతుంది ప్యారలల్ గా కనెక్ట్ చేసినప్పుడు. బట్ సిరీస్ కేసులో అయితే టోటల్ హెడ్ లాస్ సమ్ ఆఫ్ అవుతుంది. H equals to H1 plus H2 plus H3, isn't it? Total head H equals to H1 plus H2 plus H3 సిరీస్ లో అయితే. అదే ప్యారలల్ గా ఉంటే H1 is equals to H2, H2 is equals to H3. సో దీనికి డిఫరెన్స్ అర్థమైందా? సిరీస్ లో అయితే Q equals to Q1 equals to Q3, ప్యారలల్ లో అయితే Q equals to Q1 plus Q2. సిరీస్ లో అయితే హెడ్ లాస్ H equals to H1 plus H2 plus H3. అదే సిరీస్ ప్యారలల్ గా అయితే H1 is equals to H2. సో వైస్ వర్సా, దీనికి డిఫరెన్స్ ఉంది. అక్కడ సిరీస్ లో హెడ్ సమ్మేషన్ అవుతుంది, డిశ్చార్జ్ ఈక్వల్ అవుతుంది. ప్యారలల్ లో డిశ్చార్జ్ సమ్మేషన్ అవుతుంది, లాసెస్ ఈక్వల్ అవుతుంది. So based on that we can say the equation will be 4F1L1 V1 square by 2Z D1 is equals to 4F2L2 V2 square by 2Z D2. And if F1 is equals to F2, then the equation will be L1 V1 square by 2Z D1 equals to L2 V2 square by 2Z D2. And here the discharge will be of summation, that is Q equals to Q1 plus Q2. So that is the main difference. Confuse avadandi. Daniki meeku difference arthamainda. Series lo discharge equal, parallel lo head equal. Series lo head summation avutundi, total head will be summation. Parallel lo discharge summation avutundi, total discharge equals to Q1 discharge in the first section plus discharge in the first pipe plus discharge in the second pipe. So that is the main difference between those two. So let's discuss a problem. A main pipe divides into two parallel pipes, which again forms one pipe as shown in this figure like this. So ilani ee pipe two pipes ga divide ayyi malli oka pipe ga connect ayindi. The length and diameter of first parallel pipes are 2000 meters and 1 meter respectively. The length and diameter, length 2000 meter and diameter 1 meter. Then for second one, the length 2000 meters and diameter 0.8 meter. So pipe diameter change అయింది. Find the rate of flow in each parallel pipe. అంటే Q1 కనుక్కోవాలి and Q2 కనుక్కోవాలి. If total flow in the main is 3 meter cube per second, అంటే total discharge Q value ఇచ్చేసాడు. 5 minutes. I will choose. The flow in the main pipe is 3 meter cube per second. Then coefficient of friction for each parallel pipe is same and equal to 0.005. So problem ఏం చెప్పాలంటే ఒక పైప్ 2 pipes గా డివైడ్ అయ్యి మళ్ళీ ఒక పైప్ గా కనెక్ట్ అయిపోయింది అన్నమాట. అండ్ ఫస్ట్ పైప్ కి లెంత్ అండ్ డయామీటర్, సెకండ్ పైప్ కి లెంత్ అండ్ డయామీటర్ ఇచ్చేసాడు. లెంత్ డయామీటర్ ఇచ్చిన తర్వాత ఈచ్ పైప్ యొక్క రేట్ ఆఫ్ ఫ్లో క్యాలిక్యులేట్ చేయమన్నాడు. అంటే Q1 కావాలి, Q2 కూడా కావాలి. అండ్ ప్రాబ్లంలో ఏమి ఇచ్చాడంటే టోటల్ ఫ్లో ఇన్ ద మెయిన్ పైప్, టోటల్ ఫ్లో, టోటల్ డిశ్చార్జ్ Q వాల్యూ ఇచ్చాడు. Q1 Q2 క్యాలిక్యులేట్ చేయమన్నాడు, Q ఇచ్చేసాడు. Q ఏంటంటే 3 మీటర్ క్యూబ్ పర్ సెకండ్. అండ్ కోఎఫిషియంట్ ఆఫ్ ఫ్రిక్షన్ ఇన్ ద ఈచ్ పైప్ F1 అండ్ F2 వచ్చి సేమ్ 0.005 అనేసాడు. సో ఇప్పుడు మనం క్యాలిక్యులేట్ చేయాల్సింది Q1 అండ్ Q2. సో లెట్స్ రైట్ ద గివెన్ డేటా. L1 ఇచ్చాడు, D1, L2, D2 ఇచ్చాడు అండ్ టోటల్ డిశ్చార్జ్ Q ఇచ్చాడు. F1 equals to F2 equals to F, that is 0.005 అన్నాడు. క్యాలిక్యులేట్ చేయమనింది Q1 and Q2. So for if the pipe is in series, then we have the equation Q if the pipe is in parallel, pipe parallel గా ఉంటే the equation will be Q equals to Q1 plus Q2 and the value is equals to 3. Okay, so ఇక్కడ మనకి అన్ని వాల్యూస్ ఉన్నాయి except the velocity. సో మనకి ఈ ప్రాబ్లం నెక్స్ట్ ఇంకోటి ఏంటంటే పైప్స్ ప్యారలల్ గా ఉంటే మనకి అనదర్ కండిషన్ హెడ్ లాసెస్ ఆర్ సేమ్. సో టేక్ ద కండిషన్ హెడ్ లాసెస్ ఆర్ సేమ్ కాబట్టి రైట్ ద ఈక్వేషన్ దట్ ఈస్ HF1 is equals to HF2. 4F1 L1 V1 square by 2Z D1 equals to 4F2 V2 square by 2Z D2. Here we know the value for friction, we know the length, we know the diameter and we know G value. Substituting all the values, we can get value of V1 in terms of V2. V1 equals to V2 by 0.894. So let's substitute the value. Q1 is equals to A1 into V1. We know the diameter and we know V1 equals to V2 by 0.894. So let's write the value in terms of V2. Q1 is in terms of V2 and similarly Q2. Q2 is also A2 into V2 and here also we can write the value in terms of V2. So, and we know that Q is equals to Q1 plus Q2. ఈ ఫార్ములాలో మన Q1 and Q2 values ని సబ్స్టిట్యూట్ చేద్దాం. That is in terms of V1 or in terms of V2. So substitute చేస్తే Q1 plus Q2 is equals to 3. ఇదేనా? Q1 plus Q2 is equals to 3. So substituting the value, we can get the value for V2 as 2.17 meters per second. So ఈ V2 value ని తీసుకెళ్ళి V1 equation లో substitute చేస్తే we can get V1 also. Then it will be V1 is equals to V2 by so on so, and already we have calculated V2 from Q equal to Q1 plus Q2, and then we can get V1. So now we have V1 and V2 also, then substituting both the values, the value will be Q1 will be so on so, that is 1.906 meter cube per second, and Q2 will be 1.094 meter cube per second. So ఇక్కడ ఏంటి ప్రాబ్లంలో అన్ని ఇచ్చాడు, Q1 Q2 క్యాలిక్యులేట్ చేయమన్నాడు. సో Q1 Q2 క్యాలిక్యులేట్ చేయాలంటే మనకి వెలాసిటీస్ తెలియాలి. ఎందుకంటే Q ఈక్వల్స్ టు AB, ఏరియా అంటే వెలాసిటీ కదా, ఏరియా అంటే డయామీటర్ బేస్ చేసుకుని క్యాలిక్యులేట్ చేయొచ్చు. వాట్ అబౌట్ వెలాసిటీ? వెలాసిటీ క్యాలిక్యులేట్ చేయడానికి ప్యారలల్ పైప్ కి ఉండే అనదర్ కండిషన్, ఫ్రిక్షన్ ఇన్ ద ఫస్ట్ అండ్ సెకండ్ పైప్ విల్ బి ఈక్వల్, అంతేనా? సో దట్ ఈస్ HF1 ఈక్వల్స్ టు HF2. దీని నుంచి అన్ని వాల్యూస్ సబ్స్టిట్యూట్ చేస్తే V1 we can get V1 in terms of V2. So now we can substitute these values in Q1 and Q2 formula. So formula substitute cheste we can get Q1 and Q2 also in terms of V2. సో వచ్చిన తర్వాత ఈ వాల్యూస్ని తీసుకెళ్ళి క్యూ ఈక్వల్స్ టు Q1 ప్లస్ Q2 ఈక్వల్స్ టు 3లో సబ్స్టిట్యూట్ చేస్తుంది. So substituting and simplifying this, we get V2 is equals to 2.17 meters per second. And now we know the value for V2. ఈ V2 వాల్యూ తీసుకెళ్ళి ఇక్కడ మనకి V1 కి ఒక ఈక్వేషన్ వచ్చింది కదా, ఇందులో సబ్స్టిట్యూట్ చేస్తే V1 కూడా వచ్చేస్తుంది. So now we know V1 and V2 so that we can calculate Q1 Q2 as A1 V1 and A2 V2. Isn't it? So very simple formula and simple solution. Just మీకు తెలియాల్సింది ఏంటంటే ఫార్ములాస్. సిరీస్ కి అయితే ఫార్ములా ఏంటి, ప్యారలల్ కి అయితే ఫార్ములా ఏంటి, మీకు ఈ కండిషన్స్ ఈ ఫార్ములాస్ తెలియాలి. ఇవి తెలిస్తేనే we can solve any problem. Is it clear, guys? Guys, do you understand about how to solve the pipes whether which are connected in series and parallel? So nothing is difficult. మీరు ఏం చేస్తారంటే సింపుల్గా ఒక పేపర్ తీసుకొని ఈ టాపిక్స్కి రిలేటెడ్ ఫార్ములాస్ అన్ని నోట్ చేసుకుంటూ వచ్చండి. మీకు ఫార్ములాస్ తెలిసి లాజిక్ అర్థమైతే మాత్రం యూ కెన్ సాల్వ్ ఎనీ ప్రాబ్లం, రైట్? ఏ ఫార్ములా, ఏ టాపిక్కి ఏ ఫార్ములా యూజ్ చేయాలి, ఏ లాజిక్ బేసిక్తో దీన్ని సాల్వ్ చేయాలి అది తెలిస్తే చాలు. దేనికైనా సరే మీరు మెయిన్గా యూజ్ చేసేది కంటిన్యూటీ ఈక్వేషన్. సో మీకు ఫస్ట్ తెలియాల్సింది కంటిన్యూటీ ఈక్వేషన్. Q ఈక్వల్స్ టు A1 V1 is equals to A2 V2. ఇది తెలిస్తే యూ కెన్ సాల్వ్ ఎనీ ప్రాబ్లం. ఇస్ ఇట్ క్లియర్ గైస్? మీకు అర్థమైందా చెప్పింది? డూ యూ హ్యావ్ ఎనీ డౌట్స్? ఏదైనా డౌట్స్ ఉంటే అడగండి మా. అర్థమైందా అసలు?
Yes, ma'am.
Okay guys, okay, we'll discuss the remaining topics in the next class.